Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing numericals based on chemical equation. Up to question number 268 I have discussed. Now I will continue from question number 269. I am reading the question now. 2.6 gram of a mixture of calcium carbonate and magnesium carbonate is strongly heated to constant weight of 1.3 gram. The atomic weights of calcium and magnesium are 40 and 22 respectively. State which of the following weights excess the weight of calcium carbonate in the original mixture. Again I am reading the question. 2.6 gram of a mixture of calcium carbonate and magnesium carbonate is strongly heated to constant weight of 1.3 gram. The atomic weights of calcium and magnesium are 40 and 24 respectively. State which of the following weights excesses the weight of calcium carbonate in the original mixture. First option 980 milligram. Second option 400 milligram. Third option 1.75 gram. Fourth option 0.74 gram. You keep pen and paper, only then you can solve it. Simply you can't mark it. Again one more time I am reading the question. Listen carefully. 2.6 gram of a mixture of calcium carbonate and magnesium carbonate is strongly heated to constant weight of 1.3 gram. The atomic weights of calcium and magnesium are 40 and 20 respectively. State which of the following weights excesses the weight of calcium carbonate in the original mixture. First option 980 milligram. Second option 400 milligram. Third option 1.75 gram. Fourth option 0.74 gram. Just to think, you have to tell that which of the following weights excesses the weight of calcium carbonate in the original mixture. First option is 980 milligram. Second option is 400 milligram. Third 1.75 and fourth 0.74 gram. Just to think. Here you have to write first a equation. First you have to write the equation, only then you can solve it. Suppose weight of calcium carbonate is x gram. Actually you have to calculate this only. Suppose weight of calcium carbonate is equal to x gram. Then what will the weight of magnesium carbonate? Then total weight is 2.6 gram. Then 2.6 minus x gram. That is the weight of magnesium carbonate. Correct? Then calcium carbonate is supposed x gram. And now magnesium carbonate will be 2.6 minus x gram. Now reaction you have to write, because you have heated. Then calcium carbonate and magnesium carbonate both will decompose. Then calcium carbonate, after decomposition, it will give calcium oxide plus CO2. Then molecular mass of calcium carbonate is 100 gram. How? Then calcium is equal to 40, carbon is equal to 12, oxygen is equal to 48. Total 100 gram. Then 100 gram calcium carbonate on decomposition, it gives 56 gram calcium oxide, CaO, means 40 plus 16, 56 gram. Then 100 gram is giving 56 gram calcium oxide. Then 1 gram, how much it will give? Then x gram, how much it will give? Easily you can calculate. X gram will give 0.56 x gram into x gram. Okay, 100 gram is giving 56 gram. Then 1 gram, how much it will give? 56 divided by 100 means 0.56. Then x gram, just to multiply it by x, means it will give, x gram will give 0.56 x gram. Now same way for magnesium carbonate. Magnesium carbonate will give MgO plus CO2 on decomposition. Then magnesium carbonate molecular mass is how much? Magnesium 24, carbon 12, oxygen 3 into 16, 48. Total will be 84. Then 84 gram magnesium carbonate on decomposition, it gives 40 gram magnesium oxide, MgO, 24 plus 16, 40 gram. Then same way you can calculate 84 gram magnesium carbonate gives 40 gram magnesium oxide. Then 1 gram, then 2.6 minus x gram. Easily you can calculate. 84 gram magnesium carbonate gives 40 gram magnesium oxide. Then for 1 gram, 40 divided by 84. Then 2.6 minus x gram, just to multiply it. Then it will come 40 divided by 84 into 2.6 minus x, in bracket you can write. This is the mass of magnesium carbonate. Then calcium carbonate also you have calculated, magnesium also you have calculated. Now according to the question, it has given 1.3. It was heated up to the constant weight 1.3 gram. Means sum of both calcium oxide plus magnesium oxide is equal to 1.3. It is given in question. Means 0.56 x plus 40 divided by 84 into upside 2.6 minus x, that is equal to 1.3. Then now x value you can calculate very easily. On simplification you will get x value. Then that value, x value will come 0.74 gram. X value on simplification, it will come 0.74 gram. Okay. Then now x value are knowing. They were asking question calcium mass of calcium carbonate. Then now you calculated x value, that is magnesium calcium carbonate value you wanted to calculate. Then now you got x is equal to how much? 0.74 gram. Hence correct answer is option D, 0.74 gram. Now next question I am reading. Question number 270. If LPG cylinder contains a mixture of butane and isobutane, then the amount of oxygen that would be required for combustion of 1 kg of it will be: first option 1.8 kg, second option 2.7 kg, Third option 4.5 kg. Fourth option 3.58 kg. One more time question I am reading. If LPG cylinder contains a mixture of butane and isobutane, then the amount of oxygen that would be required for combustion of 1 kg of it will be: first option 1.8 kg, second option 2.7 kg, third option 4.5 kg, fourth option 3.58 kg. Just to think, it is also based on chemical equation. All what I am discussing, all are now based on chemical equation. Here you have to write the reaction. Only then you can solve it. Otherwise, it is difficult. Just you think. Here, now I am giving you hint that you have to write the butane reaction, combustion reaction of you can say butane you have to write. Correct? In LPG cylinder, it generally butane and isobutane is filled. It is given in question also, mixture of both. Then whether it is butane or isobutane, you have to write the first. Both have same formula. Okay. Then its formula is C4H10. C4H10. Then C4H10 means 58. C4 means 4 into 12, 48. 48 plus H10. H10 means H in 1 into 10, 10. Then 48 plus 10, 58. Then C4H10 means 58 is the molecular mass. Then this require oxygen to burn. Then balanced equation if you write, actually when it will burn, it will give carbon dioxide plus H2O. Correct? C4H10 plus O2. It will give CO2 plus H2O. Balanced equation if you write, you will get 2C4H10 plus 13O2. Then you will get 8CO2 plus 10H2O. Then now this is the balanced reaction. Means for 2C4H10, 13O2 is required. 13O2 means 13 into 32. O2 means 16 into 2, 32. Then 13 into 32, how much? It will come 416 kg. 416 kg. Means 2 into 58, 2C4H10. C4H10 means 58. Then 2 mole is required. Balanced equation. 2 mole will react completely with the 10 mole of oxygen. Then 2 into 58, that is a 116 kg. Then for 116 kg, 116 kg, how much oxygen is required? 416 kg. To burn completely 116 kg C4H10 means butane and isobutane. For that 416 kg oxygen is required. Then for 1 kg, very simple way, that 416 divided by 116, it will become 3.58 kg. 3.58 kg. Option D is correct. Here you should not confuse. It is given mixture of butane and isobutane. Both have same formula. Okay. Both have same formula. Hence, balanced equation only you have to write. After that, all things will be easy. Next question I am discussing 271. Question 271. 12 liter of H2 and 11.2 liter of Cl2 are mixed and exploded. The composition by volume of mixture is: first option 24 liter of HCl, second option 0.8 liter Cl2 and 20.8 liter HCl. Third option 0.8 liter H2 and 22.4 liter HCl. Fourth option 22.4 liter HCl. Actually, what I am discussing, all numericals are little difficult, okay, but you can solve it. Always keep pen and paper with you. Again, one more time, question I am reading. 12 liter of H2 and 11.2 liter of Cl2 are mixed and exploded. The composition by volume of mixture is: first, 24 liter of HCl, second, 0.8 liter Cl2 and 20.8 liter HCl. Third option 0.8 liter H2 and 22.4 liter HCl. And fourth option 22.4 liter HCl. Okay, just to think it, you can solve it. Here, just to know that when hydrogen gas and chlorine gas will react, it will give HCl. That you know. Reaction you have to write, then we can solve it. Just to think. I think you can solve it. Just to think, how will you solve? Now I am giving you hint. H2 plus Cl2, it will give 2 HCl. This is the reaction. H2 plus Cl2 is equal to 2 HCl. This is the balanced. Means 1 liter hydrogen, 1 liter chlorine will give 2 liter HCl. Then now limiting reactant will be 11.2 liter Cl2. Actually in question it is given 12 liter H2 and 11.2 liter Cl2. Which one is less? 11.2 liter is less. For complete reaction both required 1 liter. But now this hydrogen is 12 liter and chlorine is 11.2 liter, means less. Hence only 11.2 liter hydrogen will react. Correct? And some hydrogen gas will be remaining. Then now you calculate now that now you know that full chlorine will react and H2 will be left. How much H2 will be left? Then 12 minus 11.2. 12 minus 11.2, that is the 0.8 liter will be left hydrogen gas, and it will form 2 mole of HCl. Then 2 mole of HCl means how much? 2 liter, it is giving double. According to the reaction, 2 HCl you are getting, means 2 liter. Then hydrogen left is 0.8 liter and HCl form will be how much? Then 11.2 liter completely it will react and double of this it will give, means 2 into 11.2 liter it will give. That is total 22.4 liter. Means hydrogen you will get 0.8 liter, it is left, not reacted, and HCl form is double of Cl2 because it got 2 HCl and full Cl2 reacted. Then double, then 2 into 11.2, 22.4 liter. Hence correct option will be what? Option C, 0.8 liter H2 and 22.4 liter HCl. Next question I am reading. 272. The mass of 70% H2SO4 required for neutralization of 1 mole of NaOH. 1 mole of NaOH is: first 49 gram, second 98 gram, third 70 gram, fourth option 34 gram. Again I am reading the question. The mass of 70% H2SO4 required for neutralization of 1 mole of NaOH is first option 49 gram, second option 98 gram, third option 70 gram, fourth option 34 gram. This question also you can solve it, provided you should write the reaction. Reaction right, after that you can calculate. Only you have to consider that mass of 70%, you have to calculate mass of 70% H2SO4. What is the value of 70% of H2SO4? You have to calculate. Then required for neutralization of 1 mole of NaOH you can calculate. Just to think, at least to think. If you will think correctly, then you can solve it. Thinking is very, very important. Just to think. Now, I am giving you hint. See, you have to write the balanced equation. NaOH plus H2SO4. It will give Na2SO4 plus H2O. Balanced reaction is 2NaOH plus H2SO4. It will give Na2SO4 plus 2H2O. Then H2SO4 means what is its mass? Molecular mass? Then 98. You should know directly molecular weight of H2SO4 is 98. You can calculate it also. H2SO4. H2 means 2. 2 into 1, that is the 2. Sulfur is equal to 32 and O4 means 64. After adding you will get 98 gram. And 2 NaOH. 2 NaOH means 1 NaOH means that also you should know, that is the 40 gram. And 2 NaOH means 80 gram. Then you can also tell 2 mole. 2 NaOH reacting with H2SO4. 1 H2SO4 means 2 mole. Okay, 40 gram means 1 mole, 80 gram means 2 mole. Or directly 2 NaOH means 2 mole. Then 2 mole required to react completely 98 gram H2SO4. Correct? Then now here mass of H2SO4 required for neutralization of 1 mole of NaOH, that is the 49 gram. That is clear? Mass of, for the 2 mole 98 gram H2SO4 is required. Then for 1 mole 49 gram. And for 1 mole NaOH 49 gram H2SO4 is required. Then now 70% of H2SO4, it here mass of 70% H2SO4 required will be what? Here it will be that mass of 70% H2SO4. Then you know that for 100%, for 49 gram means 100%. Then for 1 gram, how much? That here you should know that 70% you have to calculate out of 100. And here mass of 70% of H2SO4 means how much? 70% of H2SO4. Then you know it will become how much? That will be 100 divided by 70 into 49. That is the 70 gram. Okay. Mass of 70% of H2SO4. Then here 98 gram is for 100%. Then you have to calculate for 70%. Correct? 100% means 98. Then for 1, 98 by 90, this 98, not here, 49 you have calculated now. It is required 49 gram per 1 mole, that you have calculated. Then mass of 70% H2SO4 of 49, that will become how much? 100 divided by 70 into 49. Okay, that will be 70 gram. Correct? Then here only things we have to calculate 70% of H2SO4. Then here for 1 mole of NOH 49 gram is required. Okay, question it is that is written you have to calculate for 1 mole of NOH. Then for 1 mole of NOH 49 gram is required. Then 70% of 49, how much? You calculate 70% of 70 divided by 100 into 49. It will come, just to calculate, you will get 70. Okay, and correct answer will be 70 gram. And option is C. Option C is correct. Okay. Now this question, next question I will read now. Question number 273. If potassium chlorate is 80% pure, here you should know that wherever percentage will be given, you should be careful. Okay, what I discussed here 70%. Then only this is the meaningful. The pure concept you will understand, only then you can understand. You can calculate this type of these things question. Okay, because 70%, because you have taken here purity, you have to think that for 70 gram you have to take 100%. For 70 gram you have to take 100% impure. Correct? Then for 1 how much you will take? For 70% pure, to get pure, you have to take 100% impure. Then for 1, 100 divided by 70. Then for 49, 100 divided by 70 into 49. Correct? Like that way, wherever impurities will be there, you have to think like that. That just what I discussed, 272. For 70 gram pure H2SO4, you have to take 100 gram impure. Then for 1 gram, 100 divided by 70. Then for 49 gram, how much? You have to calculate. For 70 gram, you require 100 gram impure. Then for 100 divided by 70. Then for 49, how much? Then you will get 70 gram. Then now question number 273 is also based on that way. If potassium chlorate, question number 273 I am reading. If potassium chlorate is 80% pure, then 48 gram of oxygen would be produced from first option 153.12 gram of potassium chlorate, second 122.5 gram of potassium chlorate KClO3, third 245 gram of KClO3, fourth 98.0 gram of potassium chlorate. Again I am reading question. If potassium chlorate means KClO3. If potassium chlorate is 80% pure, then 48 gram of oxygen would be produced from first option 153.12 gram of KClO3, second 122.5 gram of KClO3, third 245 gram of KClO3, fourth 98.0 gram of KClO3. Atomic mass of potassium is given 39. Now you think this also you can solve it, but you have to write the reaction, balanced reaction you have to write, and then same way you can calculate like 272. Okay, question number 272 calculated same way. First to write the balanced equation. Then now I am giving you hint. 2 KClO3 reaction, when you write, you will get 2 KClO3, it gives 2 KCl plus 3O2. Then now KClO3, what is its molecular mass? K is equal to 39, Cl is equal to 35.5, and O3 means 16 into 3, 48. Correct? Add all, that is the molecular mass, and multiply by 2 because 2 mole is required. 2 mole is giving 3O2. 3O2 means 3 into 32, 96 gram. Okay. Then easily you can calculate. Now for 96 gram oxygen you require 245 gram potassium chlorate, 2 KClO3, remember. Then molecular mass into 2, that is 245 gram. Then for 96 gram oxygen you require 245 gram potassium chloride. Okay. Then for 48 gram oxygen, how much potassium chloride will be required? Easily you can calculate. For 96 gram, 245 is required. Then for 48 gram, how much? Then 245 divided by 96 into 48. For 48 gram, you require 245 gram KClO3. Then for 1 gram, 245 divided by 96. Then for 48, how much? Into 48. Then you will get, after solving, you will get 122.5 gram. Okay, because 245 divided by 96 into 48, then 48 into 2, it is 96. Then and 245 divided by 2, 122.5 gram. You require 122.5 gram potassium chlorate. But now I told you, it is only potassium chlorate is only 80% pure. Then same way, to get pure 80%, 100 gram is required. To get 80%, 80 gram you can tell. To get 80 gram pure potassium chlorate, 100 gram is required. Then for 100 divided by 80. Then for 122.5 gram, how much will be required? You will get, after solving, you will get 153.12. 100 divided by 80 into 122.5 upside. Then after solving, you will get 153.12 gram potassium chlorate. This is the correct answer, 153.12. Okay, 153.12 means first option is correct. Option 1, option A. Now next question I am reading. Question number 274. The mass of oxygen. Now actually 273 I discussed. Now I am leaving only here. Okay, because it will take more time. Up to 273 I have discussed. 274 onward I will discuss in next class. Okay, thank you.